I had a presentation at the last ONF Connect, so folks that have seen that might see a bit of similarities. I hope I'm not too much contradicting what I said 9 months ago. This is about the programmable service edge. Service edge, in our definition, is part of what you usually see as a BNG. Last time I was here, this was the work of 2 people in DT together with some partners. Now it's the work of a big team. It's if you've been here yesterday, we have sliced A4 into multiple teams. There's one team that takes care of the functions. These are fun guys, but their team name is also the fun team. And it's really fun to work with them. Sabine Super is heading that team. I'm the guy who's presenting here together with the help of Sean. Access 4.0 is a program we run in Deutsche Telekom to significantly redesign the way we produce access networks, the way we produce internet access towards our customers. You probably have heard about the white paper that we issued together with Telefonica, AT&T, and Arthur D. Little that explains a bit more the background, why we're doing this. And our initial driver and current driver is still finding a way and making something happen to produce cost efficiently access networking, and then at the next stage be able to onboard services that we currently envision but are not able to implement.
I'm staying here just in case people want that.
Okay. No, but this is great assistance. Thank you, Sean. I owe you a beer.
You can also influence the speed that is.
Yeah. I tend to talk too rapidly. So this is actually later during the day, there is a presentation from Robert and myself on a bit more on the whole program. So Access 4.0 builds mini data centers that are really like the initial idea of CORD has been. It's like spine leaf fabric and blades in there and mini data center technology with the purpose of focusing on providing broadband access. Now, one of the things here, merchant silicon and bare metal, and this is basically what this talk is about, a bit of hardware-software split. The focus of this talk is that. The BNG, for those who are not that familiar or working daily with BNGs, broadband network gateway is in the network along the chain up to the IP core network where you have the routed network. You have your access device at home, your Wi-Fi router. You connect to an access node like an OLT that the other Sean was talking about a few minutes ago. In some cases, you have an aggregation network. Some cases, you don't. And then you have the point where the subscriber session is terminated, where the layer 2 tunnel, that's a one-to-one mapping of basically what's happening in your house, is terminated, and you receive an IP address. And then you walk off to the internet. So the BNG can be, call it a split personality. It's not me, it's the BNG. So that is like 2 main parts. Number 1 is that it terminates all the tunneling protocols, and number 2 is that it provides the services. And if you take a deeper look on the packet walk through a BNG just to terminate subscribers, it's pretty complex actually, and also the order of how you, in which order you apply the rules matters. And if you look at the ONF demo that Carmelo and Saraf have developed and the description of that, you will see an iteration and a further version of this block diagram. So this is what we call the service edge. And this is, if you're interested in the routing part, you can leave now, actually. The service edge part is what I will be talking about. The other part, the routing part, is something that's, in our case, is implementing ISIS and BGP and all the MPLS to connect to the IP network. As I said, I'm not talking about this. We put aside the routing part, and we're moving on with the service edge part. Thank you, Sean. So there's multiple ways how to integrate a BNG to a port, being it a Seba port or a DT port that is really very similar to a Seba port. Number 1 is, and I know that some operators probably in this room prefer at the beginning, this version is like you have your service edge just sitting next to your port. The nice thing about that is you don't need to do everything in one step. You basically have your spine leaf fabric, and you make sure that everything that comes out of Volta through, in the Seba case, the trellis fabric, gets nicely steered to your BNG. And then at the BNG, there needs to be some sort of a listener port at the line cards that terminates that. The good thing is you keep your BNG, you keep your provisioning chain towards the BNG. The bad thing is you end up developing a couple of functionalities twice. For us, that's also an interesting scenario for services we might not be able to, so subscriber services we might not be able to implement in first place in our implementation. So we could still think about taking the flows and asking Fabian and team to redirect the flows to an external BNG for pretty complex services. One of the things that's a general thing, don't try to solve everything in first place, because then it just overloads your project. So that's a good migration scenario, actually, and I have nothing against this, and Seba allows for that. Seba also does allow for the other two. Now, option number 2, and there's always like things in between, but option number 2 on my slide is the internal appliance. And this is actually what was also described in Cord and built with the virtual home gateways a while ago, which means that in your spine leaf fabric, you implement your service edge as an appliance or as a virtual network function in the rack. This is also like you would build it if you really do NFV and you want to put everything on x86. Actually, when we started, we wanted to build this. And then in the course of the project, we figured out that we'd rather go to number 3. And the reason for that is cost. We've done the cost model. We've checked how much power, how many servers, what's the performance. And it turned out number 3, which I will explain in a minute, is the better one. The good thing about this, it's in case you have it in the fabric, it's already part of the fabric. You can go to Seraph and say, hey, we need flow steering to this entity, and you can include it in the management because it's not outside the pod, it's in the pod. One of the other thing is, what I don't like is, actually, when I was a teen, Germany got reunited. The wall came down and we had a lot of east-west traffic, and I really loved that. But in the data center, if I can avoid it, right, it's like hairpinning the traffic. Now, number 3 that we came up with is, and that is something, first of all, you need your glasses. You got your glasses on because the service edge is here, here, and here. What we said is, we looked at it, and we looked at the data path. And we saw life of a packet. A packet comes from your home and it hits the OLT. You say, hi, Qumran. Then you hit a Tor and you say, hi, Tofino or Qumran. Or so the second highly powered ASIC. And then you hit the spine, and then there's another ASIC that has a lot of capabilities. And then you run off to the internet. So we thought, like, let's use the ASICs on the data path. And there's multiple ways to do that, and I will come to that in a minute. And also, we said the routing, so the BGP, OSPF, ISRS, what have you, that should also be taken out, and the fabric is doing that. Trellis is doing that. Our routing implementation also does it. Actually, that's a thing you can also do in option number 2. Important thing is that whatever path you choose, and there are ways in between, the SDN control application, so the controller shall accommodate for all of these. And we've built the system like that. I know, and Seba is built like that, and Trellis also supports that. But our target is number 3. Thank you, Sean. How am I doing? Okay. When you want to build this SE, the service edge on bare metal switches, when you go into the details, you figure out, Jesus, last 20 years as network operators, we had a lot of fun, but we have created a lot of features. And so here are the key features for BNG. And I will just pick a few of them. The slides will be distributed. So should I be on the photo? It's like, you will get the slides anyway, maybe together with Sean. So Q&Q Ethernet termination. So stacked VLANs is something that's super common in service provider networks. In our fabric, we also use MPLS labels to separate the traffic. I'm not so much keen on a third Ethernet label. I know it's possible, but it's like, looks a bit weird to me. But having said that, if you want to implement a data path on merchant silicon and you have another header, you need to make sure that there's a stage that can take off this header. On fully programmable devices, that's a bit easier compared to partly programmable devices, but you also need to have the stages to do that. PPP over Ethernet, that caused really a lot of headaches when we thought like, oh, we still do PPP in Germany and we're going to do it the next 5 years, and the silicon didn't support that. Gone. All the silicon we use is able to terminate PPP over Ethernet. Tick. Authentication, the whole radius integration, yeah, for sure. That is needed. Then packet filters, ACLs per subscribers. When you build something like this, have a good look at, are those individual ACLs, or do you have, does every subscriber has the same access control list? If you have 5 sessions, you can do whatever you want. If you have 5,000, 50,000 sessions, that's a different thing. Keep that in mind at the beginning. Anti-spoofing to make sure that you only use the IP addresses that you had been assigned to. The green ones are actually the ones we do already have. Hierarchical QoS is pretty tricky, and when you look at silicon today, and if you want to have carrier-grade multi-stage QoS, some of them are not applicable without any help of other devices. Multicast, we're still watching TV. My kids don't, I do, so we need multicast. L2TP is something we recently achieved. So last time I think I was announcing L2TP or saying we work on L2TP. We do have L2TP on merchant silicon. Lawful interception is something we built together with BISDN. Is Hagen here? No, Hagen's not here. So I did some advertising for his company, and he's not here. Yeah, the MPLS-based. You tell him, right? So this is a screenshot, and I made it so blurry that you can't read through it, so you don't ask me any questions on this. But it's really working, and that is thanks to our partners and especially the fun team, which I introduced before. Yeah, you know, this was done immediately after dial-in, before the first keep alive, and it's really hard to do this. Like, why did you read this? Next time you sit in the back. When is your presentation? I want to ask questions. You got out of that. Okay. I need to speed up a bit. Here's a sketch. 50. Thank you. Thank you, Sean. 50, right? Thank you. No, you said yes. Thank you. No, I will not bore you with too much stuff. So this is a view, a high-level view on how we think the stack of technology should look like. And here's the legend. This is the magenta stuff. This means like this is our built by DT, owned by DT. Owned by DT doesn't mean we're not going to open source it, but sometimes we build stuff that is not of use to anybody else except for us, so why should we bother you with that? Blue should be open, black should be closed or is closed. So one of the things, well, let's face it, we're moving to software, but we will not be able to implement every function on this planet by just hiring a couple of software engineers and letting them do this, right? It's like there's a lot of space for proprietary technology, for domain experts to build cool products and to differentiate based on the functionality and the performance. The thing that I'm super keen on is taking this hard-to-copy technology but put APIs around it. So open APIs, accessible APIs, so that if tomorrow somebody comes around and says, hey, I can build this, and I'm 10 times faster or 5 times cheaper, or it just looks greener, greener power consumption, that I want to be able to swap this out. And every partner that's working with us knows that this is an entry condition to work with us on APIs, to support the APIs, and to help us making sure that we can swap them out. Competition only based on performance. So here you have the device ODM, here you have the chips, Linux, and then comes the first API that we don't have yet, but we're working on that. Then comes the control plane of the service edge, so you see basically user plane, control plane. And then we have an API that our SDN controller talks to. If you want to hear something about SDN controller, Fabian here with the green shirt will present 5:30 or something. Yeah. So the control plane in our current implementation that we are taking to production is running on the box itself. So it's a bare metal switch. It has a CPU. It has a PC board on it. They run Docker containers. We run it there. Some of the good stuff is you have less delay. You don't have an additional protocol. You can go directly to the host path. We do not have distributed state in these mini data centers. I know of large deployments with control plane, user plane split, where they have like, I don't know, 1 million subscribers on one converged control plane, and they really need to independently scale out and in. This is not the case in these tiny data centers. Another thing is that if you don't have a protocol in between your control and user plane, there's less synchronization issues. We do support the development of PFCP because we think this makes sense, but at the moment on the productization track for Access 4.0, we don't use it. Another thing that is important when you have your silicon and you send packets through and then you need to fragment some of them, or you need to implement keep alives. Not every silicon has all these functions on the chip, so you need to go through the host path to the control plane, and then it's a bit easier if the control plane or the daemon that's handling that is nearby. Yeah, and about programmable chipsets I did already talk. Thank you, Sean. This is like your logo here. There's a company around, I think, that also there's a building that your logo here. I also have a your logo here. And actually, I did a photo 9 months ago, and it was also your logo here. Actually, I wanted to have my logo there, but it didn't work out, but I see I'm working on that. No, this is on the left-hand side. It's the same picture that I showed. The devices, the hard-to-copy technology, the one that shall be open, the Magenta POW, the pod access orchestrated, our SDN controller that can be open based on feedback if you want us to open it. And then this slide exists in 2 versions. There's an internal version that I edit like every 2 weeks, and then there's the one I can show in public. These logos here are the 2 companies we currently work with to get this into production. This doesn't mean we're going to work in that setup for the next 50 years, but we're working on this and we're getting it into production, and if it's working, that's pretty good combination, and it's a lot of fun working with those. I had quite some offline talks here, and I know that I can put more logos on, and I'm happy about that. So the internal version has a lot of more logos already. And like a year ago, there were not so many logos here, and there were some we were like, maybe not. Things have changed. And that makes me happy because that sort of also shows us there is an ecosystem. There is interest from companies that know how to build these components to work with us. Okay. This is the one I could potentially skip. You know Seba, right? Yeah. So we're part of Seba, so we make sure that Seba is aligned with what we're doing in our production. And BNG in the aggregation switches. So Seba allows for the BNG inside and the BNG outside. Let's skip this because of time. Here's a couple of bubbles I want to share with you. Is this the moving on slide? Is that really the? Sorry, we need to go. Did we skip one? Okay, anyways, it's like that. Moving on. Okay, so I did reading out some of the bubbles. APIs towards the silicon are important. You know, vendor locks shall be avoided, but if I have the super duper XYZ chipset and I cannot take it out, then I have another vendor lock, or same on the software side. So we're really keen on having consensus in the whole community, which means you on the APIs, so that we can also allow for new entrants in the business. We are part of Seba. We're bringing the stuff in. I need to spend some time with Carmelo, who's standing there in the back, right, on making sure that the documents and the prototypes also include our experience there. We are going into production 2020. Seba shall cater for different deployment variants. Just put it here. That's clear. I know that depending on whom you talk to, they have different plans. There's migration. APIs, I hope we can contribute that to Seba, not today, because I'd rather provide the APIs once I know it's running. So I know it's running, the BNG is running, but I want to know that the APIs are the right ones. And whoever wants to talk to me about APIs or to the teams, please come to me. Then there's another thing, again, being Germans, driving a lot on the Autobahn, most importantly is look left and right, because it's like pretty fast cars there. We always look left and right with regards to technology. At the moment, we're super sure that the merchant silicon thing is the thing to do, but we're always looking at different variants of silicon types, and virtualization is a bit, with regards to the cost model, behind, but I'm open to everything here. We're not religious about anything. At the moment, it's a clear case for the bare metal switch. And we're all talking a lot here about openness and open source, and that's super good. But having headed a team that went to the 3GPP, I also know that standards are pretty important. So we need to make sure that we nicely work together with the standards body. This is shameless advertising for the next Deutsche Telekom talks. Skip, because I had additional material. Yeah, one of the slides seems to be missing, but it doesn't matter. I think I'm good with this one. Now I'm confusing you, right? I think I've reached this one. Well, thank you very much, and I don't know if there's time for questions, but thank you.
We have 5 minutes for questions. Anybody?
Yeah, I just had a quick question. The closed source, that was your P4 compiler and run or control plane?
Not really. So
you had the silicon.
Yeah. Let's go back to this picture. Let's see if this works without Sean. It does. This is the control plane. So the P4 program actually runs here on the merchant silicon. So
what's talking like the P4C to the P4U, basically.
No.
That's bonus.
Is anybody in the room who has written P4 programs for 2 different targets? What's the main finding?
It's doable.
It is?
It is doable.
Yes, but?
You need a lot of pragmas and other stuff.
It's platform dependent, right? So the abstraction layer, in my view, needs to be 1 level above the P4 program.
Sir, do you have a question? Yeah. And please keep your microphone close to your mouth.
I'm wondering at which level you are planning, or you are already applying the quality of service at the at the OLT, or at the edge BNG, or at the BNG center.
Okay, that's a good question. Did we agree offline on you asking this question? No. We have implemented the QoS on the top of the rack switch in the hierarchical shapers of the Qumran chipset. One of the reasons is that if you have one enforcement point, life's much easier on the control plane side. It's an absolutely valid design to say on the top of the rack switch, we terminate the session, but we do the QoS somewhere else. Like, for instance, on the OLT that might also have a Qumran. The thing is, in our case, and that really depends again on the deployment, is the requirements we have on accounting. So if you, for instance, had a Tofino on the top of the rack switch and you counted the packets, you send them down to the OLT, looking at our OLT guys, and they start happily dropping packets. There's something wrong with the accounting then, right? And so we were at the moment forced to have everything in the same enforcement point, and we have implemented that. This adds complexity, and I would really like to get rid of that. Actually, there was one slide missing here, and I just want to make sure that I can say that now. I think it fits. We talked a lot about the software part, but we are currently building a switch based on Broadcom chipsets that we will run this software. And currently we use an available Qumran-based switch, but and I don't want to steal the thunder from Winnie Lin and Carsten Michel's show at the Open Compute Summit in Amsterdam, but they will present a design, Delta Electronics and Deutsche Telekom together, that will incorporate a chipset that can do all the accounting and the QS. Did you make my slide disappear, Sean?
I ate it.
You ate it! Jesus.
Anybody else has any question? If not, thanks, Hans-Joerg, for the presentation.
Thank you.